Pressure. It is a common observation that a person walking on a high heel shoe makes deeper marks while walking on a soft ground than when ordinary shoes with flat heels. It is also easier to push a sharp pin through a cardboard than it is to push a blunt one through the same material using the same force. In these two observations, the sharp pointed heels dig deeper on the soft ground because the weight of the body acts on a small area. Also, the sharp pin penetrates easier on the cardboard because the applied force acts on a small area than when the blunt pin is used. So we note two important things: small area and force leads to deeper penetration. On the soft ground. We also note that a force acting on a surface produces a penetration effect. Force causes a penetration effect. From this we get the definition of pressure. Pressure is related to force and area, and we define it as the force acting perpendicularly per unit area. Pressure is the force acting per unit area. From the definition, pressure P is equals to force F over area. Force is measured in newtons, area is measured in square meters, and therefore the SI unit of force, of pressure is given by the SI unit of force divided by the SI unit of area, which is Newton per meter squared, also written as Newton per meter squared. The SI unit of pressure is thus Newton per meter squared, which is also called pascals. So 1 Newton per meter squared is equals to 1 Pascal, abbreviated as PE. We also have other subunits like centimeters of mercury or millimeters of mercury, which are also commonly used. We also have 1 atmosphere as a unit of pressure. Let us now look at an example. A box whose dimensions are 0.2 meters and 0.1 meters and 0.05 meters has a mass of 0.5 kilogram. Determine the maximum pressure it exerts on a surface and the least pressure it exerts. Now we have already seen that pressure P is equal to force over area. If we have a box which is cuboid in shape and measures 0.2 by 0.1 by 0.05 meters, this box can be placed in different faces so that it is able to exert minimum and maximum pressures respectively. For it to exert a maximum pressure, the area in contact with the surface must be minimum, so that we have pressure maximum is equals to the same force, which is equivalent to the weight of the box, divided by the minimum surface area. The minimum surface area is the area of the face with the least area, surface. So the weight in this case is 0.5 meters, kilograms multiplied by 10. Weight is given by mass times G as discussed earlier, divided by the minimum area, which is given by, in this case, 0.1 multiplied by 0.05. This gives a numerical value of 5 divided by 0.1 multiplied by 0.05. Which is equal to 1000 Newton per square meters, or you can also write it as 1000 pascals. The least pressure or minimum pressure, P minimum, is given by the weight, which is equivalent to the force in this case, divided by the maximum area, which is equal to weight is 5 newtons divided by maximum area is 0.2 times 0.1. The maximum area now will be given by the area of the top, which is equivalent to the area of the bottom, which is equal to 5 divided by 0.02. (250 pascals). Example 2. How much force must be applied on a blade of length 4 centimeters and thickness 0.1 millimeters to exert a pressure of 5 times 10 raised to the power 6 pascals? So we have been given the dimensions of the blade as 4 centimeters and 0.1 millimeters. To determine the pressure to its SI units, we have to convert the dimensions to the SI unit of length. So we start by converting 4 centimeters is equivalent to 0.04 meters. 0.1 millimeters is equal to 0.1 over 1000 meters. Pressure is equals to force over area, meaning that force is equals to area times pressure, which is equal to area is 0.04 times 0.1 over 1000. We multiply by the pressure, which is 5 times 10 raised to power 6. This, when worked out, gives a force of 0.1 multiplied by 0.04 multiplied by 5 then multiplied by 1000. This gives a force of 20 newtons. So in order to exert a pressure of 5 million, we need a force of 20 newtons.